Scientific notation. In chemistry, we'll work with really big values and really small values. For example, the speed of light is about 300 million meters per second. The mass of a proton is 0.000, and there's a lot of zeros, 167 kilograms. And so when we plug these numbers into our calculations, it's very easy to make an error when you're plugging in all these numbers. It's much easier to write the speed of light as 3.00 times 10 raised to the 8 meters per second. And the mass of a proton can be 1.67 times 10 raised to the negative 27 kilograms. One thing to notice before we move on, you notice the speed of light, 10 to the positive 8, that's a big number. Positive exponents means big numbers. The mass of a proton, 10 to the minus 27, negative exponents indicate really small numbers. It's more convenient to express these large values or small values using powers. The correct form includes the format integer, decimal point, followed by more integers, times 10 raised to the n power. So in the format, we want one non-zero integer in front of the decimal place, followed by more integers based on significant figure rules, which we'll talk about in a moment. Here's an example. 1,300,000 can be written as 1.3 times 10 raised to the positive 6. So how do we get to this number? Imagine there's a decimal place. If there's no decimal place, you can add one. When you move the decimal to the left, you'll move it 6 times so that there's one non-zero integer in front of the decimal place. Here, we'll move the decimal place between the number 1 and the number 3. 1.3 times 10 to the positive 6 means that 1.3 is multiplied by 10 6 times. Likewise, we can move the decimal place to the right to make a small number, or something less than 1. Here, 0.00013 can be written as 1.3 times 10 raised to the negative 5. Negative exponents mean that the number is small, or less than 1. 1.3 times 10 to the negative 5 means that 1.3 is divided by 10 5 times. Now we can do math with these big or small numbers. Avogadro's number is a common number used in chemistry. 6.022 times 10 raised to the 23. We'll see this later. In our example, 5.0 is multiplied by 6.022 times 10 raised to the 23. The answer here is 3.0, 10 raised to the positive 24. Keep in mind the number of significant figures, and we'll talk about these rules later. At this point, it's useful to take the time to practice using our calculator. Here's an example of 3.00 times 10 raised to the power of 8, divided by 5.00 times 10 raised to the negative 7. In most of your scientific calculators, you'll notice there's an exponential function that's represented by a letter E or maybe a double E. And so I want you to learn how to use this button. So the calculation above can be rewritten in the calculator as 3.00 E 8. E represents times 10 raised to the power of, and then you plug in the number 8, divided by 5.00 times 10 raised to the negative 7. E, of course, represents times 10 raised to the, and then you plug in a negative sign and the number 7. It's important you know how to use these exponential functions. If you don't know how to use them, it's highly likely you'll plug in some wrong values or wrong functions, and you'll get the wrong answer. So at this point, take the time to pause the video, try plugging this into your calculator, and your answer should be 6.00 times 10 raised to the positive 14. You can also check your notes, and I've included several examples that you can practice.